Okay, so I don't know if you can hear me, but so you have the when you load up the website, um, just looking at Python idle or IDE. I call it idle because the program I use is called the idle, but it's an online compiler, basically like an interpreter. So you go into it, and there's like some basic code here. You can just run it to see what it does. I think it's like a calculator. Yeah, there you go. Wow, amazing. So you delete that, and then you paste my code, which is awesome. That's not it. Hold on. Uh, here, here, and then you paste it. Wait, that's the wrong one. Oh shit. Oh my god. Okay, hold on. So you go to your file thing and you open this one that I made. You select it all. And now you paste it. There you go. And now you delete this for plot reasons. Uh, right. So you get a binary data input, and then you establish a variable called binary data. So this is where you put your binary. Then you have a variable called ascii text, which you establish as a empty list. Then you make a for loop so that I is a variable. So for this variable number, which goes between like from 0 to the length of the binary data entry, you split it up into eighths because binary is read in bits, which are separated in eight like digits, and then you append. So like you add to the ASCII text list that we established earlier, which is like an empty list. You append, and this is complex. So basically, it's uh, in binary data. You append from one to or from zero, right? Because I starts at zero to 0 plus 8. So okay, so from 0 to 8, got it. And then you skip forward 8, and then you do from um like oh no, you skip to like you skip an eighths, right? Like in the range. So you like skip to 8 or something, or like to 8, and then so you have 8 from 8 to 8 or 8 plus 8, so it's a 16, right? And so you go like 8, 16, 24, 34, 32, 32, and so on. And so you split up the big old text binary string into a bunch of bits inside here, and then you grab that and you interpret it as bits by saying to read the text that's in there because you input the binary as text because otherwise it explodes, and to interpret as an integer of second kind, so that's like binary. And then you grab that integer and you change it into a character. So you use this function to change from like a number to its associated character in ASCII, and ASCII is like the numbers to text language used by most computers. And then you grab that number and you append it to the ASCII.text, or like this turns it into the number that it is in ASCII. This turns that number into the character that it is, and then this adds it to the list. And then we join all of them with this little command. Basically, you join them together with nothing in between them, and then we print it all looking pretty, like print f binary data, blah 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 blah. And then I need to hurry because my time is about to run out. But you have this image from a game called Inscryption with a bunch of ones and zeros, and so I took a screenshot and I ran it through Google Lens to get the list, or like all of this in a single line, and it's this, bang, and then you run it, and you get like the secret Easter egg, and it's a kernel code, and now I gotta figure out like what the heck is that? Oh my goodness, it's an ARG, it's a secret, and my 5 minutes are about to run out, so bye.